All right, so we're going to finish up section 6.3. We're going to look at graphing multi-step transformations. So we'll make sure that we know the proper order. And then we're going to finish up with solving equations. We're not really going to do anything algebraic today. It's more going to be graphical. That's why I have the calculators out. So it's going to involve finding an intercept. So for the take-home test, you will need access to a graphing calculator. If that's a concern because you don't have one, then again, talk to me and we'll have to figure out a time you can do it in class. Or if you don't have reliable internet, we'll figure out something you can do in class instead of at home. Okay, so when we want to graph any type of function, what's the first transformation that we always look for? And I labeled this using an A in your notes. Yep.
Isn't it a horizontal shift?
Yep, it's our horizontal shift. So that would be addition or subtraction. Yeah, let's write it like this. Inside the parentheses. Okay, with a trig function, we call it a phase shift. But it's the same thing as a horizontal shift. Okay, and that would be controlled by A. If A is positive, we move left. If A is negative, we move right. Okay, what would be the next thing we look for after we do the horizontal shift? And this would be represented by B. Okay.
Is it horizontal stretch?
Yep, the next thing you always look for in any multi-step problem is a horizontal stretch. With trig functions, we call that a period change. And remember, stretch could also mean compression. And that would be when you multiply by a number next to the x. So a period change would be determined by B. Okay, what's next? We've done the horizontal shift, we've done horizontal stretch. What's the third thing we always look for? Yep?
Vertical stretch.
Vertical stretch. Okay, that's an amplitude change. Okay, vertical stretch. Like B, it's multiplication, but it's not inside the argument, it's in front. That's the difference. And what's the last thing we always look for when we have to do transformations? Yep, Ashley?
A vertical stretch.
Yep.
Shift, sorry.
Vertical stretch, yeah, we got that, vertical shift. And with a vertical shift, plus would move it which way? Up, minus? Down. If C was negative, that would cause a reflection. And you could do that right in there. You can do this, the stretch and the reflection pretty much together. And I think that's it. Now, technically, if you do multiple transformations and you only do one transformation that affects x values and you only do one transformation that affects y values, technically they're completely separate. You could do either one first. For example, if it says to shift up and right, well, if you shift up and then right, or you go right and then up, technically you still land at the same spot. Where the order becomes very important if you do two transformations on the same axis, like a shift right and a stretch horizontally. Those are both affecting the x values. So now the order is very important. Any question on that? But if you're worried, just follow that order. Okay, so let's take a look at this. And let's first identify how many transformations are happening. I don't think they can tell me how many are happening. Yep.
Or 2.
Yep, there are 2. What's the pi over 2? What kind of transformation is that? Tyler?
Phase shift.
Yep, that's a phase shift. It's going to move it horizontally. And what about the times 2 in front? Chris?
Say vertical stretch.
That's a vertical stretch. Technically, these 2 transformations are going to affect separate columns in the table. So we could do either one of them first. Right, but we'll follow the order that I said. All right. So, Matt, what are let's start with the x's because we're going to do the phase shift first. What are my original x values?
0, pi over 2, pi, 3 pi over 2, 2 pi.
Pi. All right. And Abigail, am I going to add or am I going to subtract to all those?
Subtract.
Yep, I'm going to subtract. And Jack, how much am I going to subtract? Pi over 2. All right, so let's take care of this. Casey, what's 0 minus pi over 2? Negative pi over 2. Eli, what's pi over 2 minus pi over 2? 0. Francesca, how would I do pi minus pi over 2? What if I had this? Does that give you a hint at what you would have to do first?
I'm having a brain fart.
You gonna help her out? What's the first thing we have to do? Not the answer, just in any problem like that. You have to make sure you have something. Yeah, Ethan?
Common denominator.
You need a common denominator, because they're 2 fractions.
So then when you multiply it by 2, the top and the bottom.
We multiply the top and the bottom by 2. Yep. And 2 pi over 2 minus 1 pi over 2 is 1 pi over 2. Already have a common denominator here. Chris, what's 3 pi over 2 minus 1 pi over 2?
Pi.
Yep, it's 2 pi over 2, or we can reduce it to pi. And what about my last one? 2 pi minus pi over 2. Tyler?
3 pi over 2.
Yep, it's going to be 3 pi over 2. So these are values that are pretty common. You've seen them before. So once you kind of get the pattern, then you can go with the pattern. Okay, so we got our x's. Let's put down the y's on the outside. Zach, what are my y values for sine?
0, 1, 0, -1.
Good. Got my y values. And Ashley, what am I going to do to all those y values?
Multiply it by 2.
All going to get multiplied by 2. So this is all there is to a multi-step problem. We do one column, then we do the other column. So we're going to get 0, 2, 0, -2, 0. So the final answers I'd be looking for is what are in that table. Each one of those values would be worth 1 point in the problem. Okay, any questions on that? Now we'll make a sketch. Okay, on the y-axis I need to go probably by 2's. That would work out pretty good. On the x-axis, I could use those labels right there. So negative pi, that's negative 1 pi over 2, 0 pi over 2, positive 1 pi over 2, positive 2 pi over 2, but we're just going to call that pi. And the next one is 3 pi over 2. If those were all in degrees, you'd see very easily the pattern. That's negative 90, 0, 90, 180, 270. They're all separated by 90 degrees. All right, and now plot your points. Negative pi over 2, 0. 0, 2. Pi over 2, 0. Pi, negative 2, and 3 pi over 2 back to 0. That is your sketch. Questions on that one? Okay, so I had a phase shift, or horizontal shift, and amplitude change. What is the amplitude? Let's say I asked that. What's the amplitude of that graph? Jake?
2.
Yep, it is 2. What's the period of that graph? Yeah?
Pi over 2.
No,
wait, no, 1.
not pi over 2, no, or 1. Anyone have another guess? Chris?
Is it just 2 pi?
It's 2 pi. There was no period change in this problem. So the standard period is the period of this. It's 2 pi. Remember the formula is 2 pi over b. B is the number that's in front of x, but look at the number in front of x here. It's a 1. So, no period change. All right, let's try this one. 3 cosine 2x. What type of transformation is the 2? What's that doing? Tyler?
Period change.
That's period change. Yep, changing the period. And the 3, well, it's a vertical stretch, just like we did last time. Those 2 transformations we just said, are they going to affect the same column, or are they going to affect different columns? Yep, that's different. We're stretching left and right, and we're stretching up and down. It technically doesn't matter which one you do first, but we'll follow the order we always do. All right, let's put our x's. And let's put our y's off to the side. And our answers will go in the table. Okay, can anyone tell me what I'm going to do to all the x values? Yep, Ethan?
Divide by 2.
Divide by 2, or that's the same as
1/2.
multiply by 1/2. Can you tell me what you get if you divide all those by 2?
0.
Mhm.
We'll have pi over 4.
Good.
Pi over 2.
2.
What's that? 3 pi over 4.
3 pi over 4. Good.
And that one was pi.
Pi. Okay, so there's all my x values. We can divide them by 2. And now, Jake, what am I going to do to my y values?
Multiply them by 3.
Yep. Multiply them all by 3. And Sarah, if I multiply by 3, can you tell me what I get?
3, 0, negative 3, 0, 3.
Perfect. And that's my table. Okay, sketch. We can do it. Nothing really new to learn from this sketch versus the last one, but let's just set it up. I would go probably by 3s on the y-axis. And the x-axis, well, we can use the labels we already have. So we've got 0, and we've got 1 pi over 4. Technically, that's 2 pi over 4, but we reduce it. That's 3 pi over 4, and that's 4 pi over 4, but again, we reduce. Okay, plot your points. So 0, 3, 0, negative 3, 0, back to 3. And there's your sketch. Okay, any questions on that one? All right, so far we haven't done a problem where the order really has been important. Let's do, let me do one where the order is important. Let's do sine of, and let's do 5 sine x minus 3. So now I'm doing a vertical stretch and a vertical shift. The order matters. It matters for the same reason it does in PEMDAS. Think of a number in your head and try timesing it by 5 and then minusing 3. And now take that same number that you were thinking of and minus the 3 and then times it by 5. You're going to get a different answer. So which transformation would we handle first? The vertical stretch or the vertical shift? Okay?
Vertical stretch.
Yep, we're going to do the vertical stretch first. Nice thing is we're only going to have to work with the y values, so the x values are not changing. 0, pi over 2, pi, 3 pi over 2, 2 pi. All right. Matt, what are my original y values for sine?
0, 1, 0, negative 1, 0.
Okay. And Abigail, we're going to handle the vertical stretch first. So how are we going to do the arithmetic with these points?
By 5.
We're going to multiply them all by 5. Now we have to handle the shift. After we multiply by 5, what are we going to do? Yep,
Minus 3.
we're going to minus 3. Move this out of the way. Oh, that's not what I want. Try it right. Let's just. Alright. So, let's write down my y values. Eli, can you tell me what my y values will be?
Negative 3, 2, negative 3, negative 8, and negative 3.
Okay, since I just made this problem up, my grid's probably not going to be big enough, so I'll scale it if I need to. I need to go all the way down to negative 8. So, what I'm going to do is, I like the bold line to represent the axis. I'm going to actually just move my axis up here like that. And see if I can, oh boy, I don't want to mess it up. So let's call this 0. Oh, just move that over there. Okay, so 0, negative 1, 2, 3, 4, 5. I'll just extend it by hand. So we'll call this negative 1, 2, 5. And actually, I might be able to click on them and make them longer. Let's see. Perfect. Let's just extend that. And we need a few copies of this. almost where I want them. So -6, -7, close, -1. All right, and my x values, let's see, we're going to use 0, pi over 2 pi, standard x values. All right, and just graph the points. So 0, -3. All right. Pi over 2, we're at 2. Okay, so pi over 2. Not the best place for that label at all. Pi, we're at -3. I forgot about that one label being up that high. Let's see. 3 pi over 2, we're at -8. So 3 pi over 2, -8. And 2 pi, we're back at -3. It is symmetrical. I don't think my line spacing is perfect, but that's fine. So it should go like this. And there's your sketch. All right, so it was stretched vertically by a factor of 5, and then it was shifted down 3 units. Okay, any questions on that one? All right, so I think that it takes care of the multi-step transformations. This is more of a graphing question. So it says find a complete graph that's on the calculator, and then identify these things: domain, range, amplitude, and period. Let's see how much of this we can do before we even graph it on the calculator. In fact, some of it you have to do before you graph it. All right, let's start with the amplitude. Probably the quickest one. What's the amplitude of 4 sine 3x? Francesca?
4.
4. Okay, so we got that. How about the period? What's the period going to be, Jake?
Would be 2 pi over 3.
Yep, it's 2 pi over b, but in this case, b is 3. The reason that comes in handy is because if they say sketch it on the calculator and describe a window that shows 2 periods, well, you know the length of 1 period. So if you want to see 2 periods, double it. And that's what we're going to do. We're going to show 2 full cycles of the graph. How about the domain? Yeah? All real numbers. We've talked about that. And the range. Well, think about what the range would have been originally. What's the highest and lowest value for sine? Just sine, basic sine. Yeah?
1 and -1.
It's -1 to 1. And you're stretching by a factor of 4. So it's going to start here. It's going to go here. So what do you think my new range is going to be? And this is what I need to use for my window. Yep.
4, -4.
-4 to 4. And it does include -4 to 4 because it originally included -1 and 1. Okay. So now let's set our graph up, and I want to show 2 cycles. So what I'd asked before on the test is, what's your x min, x max, y min, and y max? All right, so let's put in 4 sine 3x. Go to our window. Okay, my x min. Well, I'm going to do 0 And what should x max be if I want to show exactly 2 cycles? Well, if you're not sure, think of how long 1 cycle is. And then if you want to show 2, you need to double it. Bailey?
8.
Well, 8's my amplitude. That's gonna have to do with my watts, my -4 to 4. But Jake?
Would be 4 pi,
Um,
or would it be 4?
so what's the length of 1 cycle?
Isn't it 2 pi?
No, we did a period change in this one.
Oh.
What was the period we found?
Oh, 2 pi over 3.
1 cycle is 2 pi over 3. So how much would 2 cycles be?
4 pi.
4 pi over 3. So I just picked 2 cycles randomly. If you wanted to show 3 cycles, you could do 6 pi over 3. 4 cycles, 8 pi over 3. Just pick 2 cycles. Now, why min and max? I wouldn't do -4 to 4. I would do -5 to 5, so you have a little extra. And then make sure you are in radians, because this period is not a degree period. If it was degrees, this would say 120, okay, but it's radians. So hit graph, and we should see exactly 2 cycles. There's 1.5, 1 3/4, 2. Perfect. So any questions how we set up the window or found those 4 things? Okay. Here's another one, kind of the same idea. Find a complete graph. This time, let's show 3 cycles. I show 3 cycles of it. All right, let's start with the domain. What's the domain of 3 sine x minus 1? Yes, Ashley? All numbers. When we get to tangent and cotangent, that's not true anymore. But with sine and cosine, it is. So that's negative, that's infinity to infinity. Range. Think about what the range would be originally, and then take into account any vertical stretches or vertical shifts. Okay?
Would be -3 to
Yeah, we'd be -3 to 3. Now, let's say it did 2 things to the range. Let's say it had this. I'm going to erase that because it's not what it is. But let's say it was. Well, first, you'd handle the vertical stretch and make your range -3 to 3. And then you would shift each of those numbers up 1. So it would end up being -2 to 4. It's the same idea as when we do a transformation, when you're finding the range. But that's not what we're doing. Okay, domain range, period. What's the period of this one? Yep.
2 pi.
2 pi, there is no period change. There's no period change and there's no vertical shift in this problem. And amplitude. Well, it's not 1 because we're doing an amplitude change. What's my new amplitude? Sarah? 3. Good. All right, so this time I'm going to leave my y's -5 to 5. That's fine. But what should my x max be if I want to show 3 cycles and I want to start at 0? Tyler?
2 pi?
Well, 2 pi is the period, so that would show exactly 1 cycle. Yeah, that would show 1. Yep.
You don't want 6 pi?
I want 6 pi. The point here is if you want to show 3 cycles, you need a window that is 6 pi wide. So technically, you could do 1 pi to 7 pi. You could do 2 pi to 8 pi. You could do negative 3 pi to positive 3 pi, that's 6 pi. You need something that's 6 pi. I usually just do 0 as the min. That's what I do. So let's look at our sketch. Oh, I didn't type in the question yet. By the way, if you want to stop it before it finishes, you just press second off, and then you don't have to wait for it to finish. So 3 sine x minus 1. So there's 1 cycle, 2 cycles, and it should end right about there. 3 cycles. Perfect. That's 3 cycles. Any questions on that? Okay, let's see. The last, I think this is the last thing. Yep, solving some equations, and we'll do a couple inequalities. Now, I'm going to show you guys how to solve these graphically. Graphically is not the most efficient way. Okay? We can do it a little bit faster. But we're going to try graphical. So, let's take a look at solving this equation. So, sine of x equals 0.4. How do you think we could solve this graphically? How do you think we could solve that graphically? Think about like a y1 and a y2 kind of thing. And then finding something after you do that. Yeah?
If you plug in 0.4 in y1 and then 2 pi in y2.
So let's plug in 0.4 in y1. And what are we plugging in y2?
And then 2 pi.
Well, if we do that, 2 pi is about 6.28. Right? And whenever you do y equals a number, you get a horizontal line. So if you do that, you're going to get a horizontal line at 0.4 and another horizontal line at 6.28. So we just have 2 parallel horizontal lines. So they're not quite what we want. Anyone have another thought about what we type in? Chris?
The sine of 0.4 and the sine of 2 pi.
The sine. Well, again, those would be 2 numbers. Because no one's told me anything with a variable yet. So if you type in sine of 0.4, you're going to get a number. And if you type in the sine of 2 pi, you're going to get another number. So you're going to have 2 horizontal lines. But remember, we're solving for x, so we don't want to just be typing numbers into y1 and y2. You got to have a variable. So, yeah?
y1 would be sine x, and then y2 would be 0.4.
Yeah, it doesn't matter which one is which, but you need to put the sine of x in one of them, put 0.4 in the other one. Okay, I already have 0.4, so I'm going to leave it. Now, how do you think I take this into account? What am they gave me that information. I got to use it. Yep.
Would it be like your x min and x max?
That's my x min and my x max. Because think about this. This is a wave, and this is a horizontal line. If you zoom out forever, how often could a wave and a horizontal line cross? A lot of times. Right? Infinite amount of times. So we have to narrow down, well, where do you want the answers? Do you want them over here? Do you want these ones? Do you want these ones? Because there's a lot of them. They want between 0 and 2 pi. All right, so let's go to our window. Put in 0 to 2 pi and hit graph. So there's your horizontal line at 0.4. There's your graph of sine x. And how many answers does it look like we're going to get? Yeah? Yeah, we get 2. And how do you think I'm going to find it? What am I going to do on the calculator to get the 2 answers? Tyler?
You would do second calc intersect.
Yeah, we're going to find the intersect. You have to do each one twice. In this case, it's twice. Could be more, could be less. But we're going to do second calc intersect. If I just hit enter 3 times, it'll give me one of them. Okay, so I got 2.73. Now, I need the one that's further to the left. So I need to take a little time to move my cursor. And then hit enter. And there's the second one. So the 2 answers are 2.73 and 0.412 if we round. And that's it. Those are the 2 answers. It doesn't matter the order you list them in. If there were 2 boxes on Elastic to type them in, you'd get credit no matter which one you put first. It doesn't matter. Okay, any other questions on that? Okay, let's try a couple more. So this one is from the book. It's on page 346. It'll be like one of the ones you do, or would have been like one of the ones you would have done in the homework. And I wrote this backwards, sorry. Notice that usually one of these is an equal to and the other one isn't. That's because, think of this as 0 and 360. Well, 0 and 360 are the same thing. Any 2 angles that are 360 degrees apart are really repeats in Trig, because you can add and subtract 360. So if you include 0, you shouldn't include 2 pi. You should include one or the other. If you include both, technically you're including a repeat. That's not what you don't want to do. All right. Anybody think they could tell me what I need to type in and clear everything out to do this one? What could I put in Y1? Yeah.
1.5.
Okay, you can put 1.5. And what could I put in Y2? Chris?
2 cosine 1/2 x.
Yep. And just to make it easier, I'm going to do 0.5x. Then I don't have to worry about a fraction. And the only thing you want to make sure of is your window is going to be sufficient. Well, that's a vertical stretch by a factor of 2. So that means I need at least -2 to 2. And I'm looking for a horizontal line at 1.5. Perfect. So that'll fit between -2 and 2. Check my window. A little extra, -5 to 5, but that's okay. Hit graph. Remember, we've done a stretch this time. So the cosine wave is going to be stretched way out. Probably not going to hit it twice in that area. It's only hitting it once. So I'm going to do second calc intersect. This time there's only one intersect. You can just hit enter 3 times and it'll find it. There you go. 1.445. I didn't check my window this time because I knew it was the same window as the last one. My window is still set at 0 to 2 pi. If you change your window, you need to check that. Any questions on that one? All right. Look at this one. Okay, so solve graphically. This would be a little more complicated. The last 2, I could have done those algebraically by hand, probably faster than using a graphing calculator. This one's a little more complicated. And the thing that really messes it up is the fact that you have this 1/2 in front of this x, and you don't have a 1/2 in front of that x. If you were going to do it algebraically. We're not. We're still going to solve graphically. So let's see how we do it. Sarah, what could I put in y1?
3 cosine, 0.5x.
3 cosine 0.5x. And Matt, how about y2?
2 sine x.
2 sine x. So we're going to have two trig waves, and we're going to see where they cross each other. Right? So we could have some more crossings this time, because they're more complicated. Let's see. Window is still 0 to 2 pi, so I didn't have to change that. Okay, how many answers does it look like we're going to get for this one? 3? Yeah, we are. We're going to get 3 of them. So we're going to just do second calc intersect over the left. There's 1. Second calc intersect. Move it back to the middle. There's 2. Right there. And 1 more. Second calc intersect. Move it to the right. And there's 3. There are your 3 answers. 1.696, 3.142, and 4.587. Questions on that one? So last one. Let's say we had a graph like, let's go back to this one for a second. And we wanted to know not where the red graph and the blue graph were equal, but where maybe the red graph was below the blue graph. If we wanted that, we wouldn't have an equal sign here. What kind of symbol are we going to put in place of the equal sign if we're going to look at a problem that has to do with where a graph is above or below? What kind of symbols do you think you'll see? Yeah?
Inequality.
You're going to see an inequality, either greater than, less than, greater than or equal to, or less than or equal to. The steps are still the same. You still have to graph them. You still have to see where they cross. We just write our answer a little different. Remember, you can't type this in on y1 using like an inequality symbol. That won't work. You have to do a y1 and a y2. Doesn't matter which one is which, just you need to remember what you're looking for. In this case, it's going to be pretty easy to remember because you're looking for where the trig graph is above a horizontal line. Okay, where the thing that curves is above the thing that's flat. When you have 2 things that curve, then you got to remember which one is which. All right, so Bailey, what could I put in y1?
2 cosine.
2 cosine x. And Abigail, what could I put in y2?
Negative 1.3.
Good, negative 1.3. Let's keep in mind what we're looking for. We're looking for where the graph in blue is above the graph in red. At least the colors I used. Where the blue is above the red. 0 to 2 pi, that's already taken care of. Okay, so where is the blue above the red? Okay. So first thing I want to look at is, let's pretend that that red line, I can't cross that, right? If I'm tracing, to cross that red line, I gotta like lift my pencil over it. It's lava. I don't want my pencil to melt. So if I want to know where that blue line is above the red line, can I trace continuously where it's above? So how many different sections are there then? If I can't trace continually, that means there's more than one section that's above the red line that I can't get to without lifting my pencil and starting somewhere else. How many sections are there? Yes.
There's 2.
There's 2. We'll call this one section 1. Let's call this one section 2. Let's start to set up our answer and then we'll fill in the numbers after. We're going to have 2 intervals here. We're going to start here and we're going to end there. That's interval 1. Where does interval 1 start? Yeah? Negative 1?
Infinity.
So we were given a very specific window to look at.
0.
Yeah, starts at 0. Including or not including?
Including.
Including, yes. So we can include the 0. Interval 1 ends right there. I don't know what that point is yet. I need to find it. But once I find it, does it include or not include the end point of interval 1?
Wait, wouldn't that be negative 1.3? Since that's where the horizontal line is?
Yes, remember we're solving for the x value, not the y value. The y value is at negative 1.3. But I don't know how far over I went on the x-axis. So would we include or not include the end of interval 1?
Not included.
Not include. I can't count where these graphs are equal. I have to count where it's above. That means do not include where they're equal. Now for interval 2, should I include or not include the start point? Yep. Not include. Again, I can't include where they're equal. I have to strictly be above, so don't include the point where they're equal. And where does this graph end? We know the number it ends at. Yep. Included or not included?
Included. Or not included.
Not included. There's no equal to under the symbol for the 2 pi. So let's set all that up, and then there's only 2 numbers we're going to have to find. So interval 1, interval 2. Interval 1 goes from 0 up to but not including some number that I don't know. And interval 2 goes from some number I don't know, not including it, up to a number I do know, not including it. Now we have to find these 2 values. How do we find that one? What do I have to do? Yeah.
Find the intercept.
Find the intercept. So second calc intersect. I do want the one on the left, so I'm not going to do this random. 2.278. So 2.278. So if you pick an x value between 0 and 2.278 and plug it into this formula, I guarantee it'll come out greater than negative 1.3. And how do I find that second one? About someone else that's hasn't said a lot. How about Casey? How do I get that second one? Yeah, we're going to find the intersection again. So second calc intersect should be good enough. And we are at 4.005. So if you want to look for values between 0 and 2 pi that you can plug into that inequality and make it true, you need to pick values that fit that criteria. All right. Any question on solving a trig inequality? Okay. So let's talk about the test. So, First of all, it would be due on, what's that, 17th of this year. So 12/17/21 at 9 a.m. That's Eastern time.
Oh my god.
I've done this before.
I mean, I can't do it.
Well, you can try to turn it in whenever you want. I'm just letting you know when it's gonna, not what to turn it in anymore. So do at that time. Okay. You will have 80 minutes. It doesn't have to be continuous. Not continuous is okay. But you have a total of 80 minutes. It'll open, well, I'll open it at, I don't know, I guess I'll set it to open at 2:40. Is that good? It's open at 2:40. That's today. Today, according to the blue square on the calendar. We know when it's going to close. If not turned in by deadline, your grade will equal the sine of 0, which equals 0. Unless you are absent, then you can arrange a different time to take it, or unless you tell me right now that you don't plan on taking it tonight. Yes?
There's no password on it, right?
There's what?
There's no password.
There will not be a password on it. No, we won't do the password. Is anybody not taking it? Everybody that's present is taking the test. Okay, does anybody have any questions about the deadline? What happens if you don't get it done? You do need access to a graphing calculator. Is that a problem for anybody? If you don't have it, you can't do it. Okay, perfect.